Chitin versus keratin, both fluctuate to some degree in their mechanical properties. Specifically, a few shellfish mineralize their chitinous exoskeletons to make them harder and stiffer. Chitin and keratin both have densities on the request for 1,200 kg for each cubic meter, contrasted with 1,000 kg for each cubic meter for water. Keratin is fairly stiffer than chitin. Exoskeletons made of keratin do exist. All things considered, reptiles and snakes are canvassed in keratinous scutes, and these must for sure be intermittently shed. Theoretical arthropod-like creature with a persistent exoskeleton of keratinous plates would need to shed in basically a similar manner as genuine arthropods, since it would confront the equivalent auxiliary issue of being not able to add new material to the plates of its exoskeleton. A keratinous structure like a fingernail, a hair, or a horn can develop by the expansion of new keratin at the base. However, a zone of development hidden each exoskeletal plate would just permit the plates to thicken, not extend along the side. The plates would probably need to supplanted in a shedding procedure to oblige development. Chitin versus keratin explained separately. What is keratin? Keratin is one of a group of sinewy basic proteins known as scleroproteins. Alpha-keratin is a kind of keratin found in vertebrates. It is the key basic material in creation of hair, nails, plumes, horns, paws, hooves, calluses, and the external layer of skin among vertebrates. Keratin likewise shields epithelial cells from harm or stress. It is very insoluble in water and natural solvents. Keratin monomers collect into groups to frame middle-of-the-road fibers, which are extreme and structure-solid unmineralized epidermal members found in reptiles, winged animals, creatures of land and water, and mammals. The main other natural issue is known to surmise the strength of keratinized tissue is chitin. Keratin comes in two sorts: the crude, milder structures found in all vertebrates and harder, determined structures discovered uniquely among sauropsids, reptiles and fowls. Keratin opposes absorption, which is the reason felines disgorge hairballs. Creepy-crawly silk is named keratin, in spite of the fact that the creation of the protein may have developed autonomously of the procedure in vertebrates. Keratin function. Keratins make up the biggest subgroup of moderate fiber, if proteins and structure a powerful system of 10 to 12 nanometers fibers, work from type I/type II heterodimers, in the cytoplasm of epithelial cells. A significant capacity of keratin IFs is to shield epithelial cells from mechanical and non-mechanical burdens that cause cell break and demise. Impedance with this job is the main driver of countless acquired epithelial delicacy conditions. Extra capacities, non-mechanical in nature, are showed in a way that relies upon the particular keratin, and on the epithelial setting. The ongoing revelation of surprising transformations influencing keratin proteins has uncovered a novel element of their mechanical help work, and has synergized with mouse hereditary qualities to uncover a job in skin pigmentation. Different investigations broadened the job of keratin proteins in controlling the reaction to favorable to apoptotic flags and uncovered their capacity to adjust protein amalgamation and cell size in epithelial cells tested to develop. What is chitin? Chitin, C8H13O5N, in a long-chain polymer of N-acetylglucosamine, is a subordinate of glucose. It is an essential segment of cell dividers in organisms, the exoskeletons of arthropods, for example, insects, and shellfish, the radulae of mollusks, cephalopod noses, and the sizes of fish and lys amphibians. The structure of chitin is practically identical to another polysaccharide, cellulose, shaping glass-like nanofibrils or hairs. As far as capacity, it might be contrasted with the protein keratin. Chitin has demonstrated helpful for a few restoratives, mechanical and biotechnological purposes. Chitin function. Chitin, similar to cellulose and keratin, is a basic polymer. Produced using little monomers, or monosaccharides, basic polymers structure solid filaments. When emitted inside or outside of cells in a sorted-out manner, the filaments structure frail bonds between one another. This adds solidarity to the whole structure. Chitin and cellulose are both produced using glucose monomers, while keratin is a sinewy protein. The different auxiliary polymers emerged right off the bat in the advancement of life, since they are seen uniquely in specific gatherings. Cellulose is select to plants, keratin to creatures, and chitin to the arthropods, mollusks, and growths. Chitin and cellulose both developed at an opportune time throughout the entire existence of life, while keratin emerged in specific animals long after plants and parasites had diverged from different eukaryotes. Chitin structure. Chitin is comprised of adjusted glucose monosaccharides. Glucose exists as a ring of carbon and oxygen atoms. Bonds between glucose particles are known as glycosidic bonds. The oxygens that normally structure hydroxyl bunches attached to the carbon ring can likewise frame a bond with another carbon rather than a hydrogen. Along these lines, monosaccharides can be connected together in long chains. Chitin is framed by a progression of glycosidic bonds between subbed glucose atoms. Chitin is unique in relation to cellulose as a result of the replacement that happens on the glucose particle. Rather than a hydroxyl gathering, the glucose particles in chitin have an amyl bunch appended that comprises of carbon and nitrogen. Nitrogen is an electrically positive atom, while the oxygen twofold clung to the gathering is electrically negative. This creates a dipole in the atom, which builds the hydrogen bonds that can shape between these particles and the atoms around them. At the point when consolidated in a framework with different mixes and other chitin particles, the subsequent structure can be a direct result of all the feeble associations between close-by atoms. Chitin versus keratin conclusion. Keratin, sinewy basic protein of hair, nails, horn, feet, fleece, plumes, and of the epithelial cells in the furthest layers of the skin. Keratin serves significant auxiliary and defensive capacities, especially in the epithelium. A few keratins have additionally been found to control key cell exercises, for example, cell development and protein combination. Chitin, a white, horny substance found in the external skeleton of creepy crawlies, crabs, and lobsters and in the inward structures of different spineless creatures. It is a polysaccharide comprising of units of the amino sugar glucosamine. As a side effect of scavenger preparing, chitin is utilized as a flocculating operator for squander water, an injury mending specialist, a thickener and stabilizer for nourishments and pharmaceuticals, a particle trade gum, a layer for chromatography and electrodialysis, a cover for colors, textures, and cements, and a measuring and reinforcing specialist for paper.